So this is the last video for this section, illustrating a couple of examples where the question wants you to leave the answer with a rational exponent rather than in radical form. So simplify leaving answers in rational exponent form. So here's first example, a to the 3/2 b to the 4/5 over a to the minus 1/2 b squared. Now, I'm going to move the a to the minus 1/2 to the top. It becomes a to the 1/2. And move the b to the 4/5 to the bottom because 4/5 is smaller than 2. So when I subtract that on the bottom, I'll get a positive exponent. So I've got a to the 3/2 times a to the 1/2 over b squared times b to the minus 4/5. And then I combine the base a ones and the base b ones. So you do that by adding the exponents. The ones on the a are easy. It's just 4/2, which of course will reduce to 2. On the bottom, I need a common denominator of 5, so I multiplied the first one, this b squared, by 5 over 5 to get 10 over 5. And then it's minus the 4/5. And then I can simplify those, and I get a squared over b to the 6/5. Now you might think, well, why doesn't he write it as b to the 1 plus 1/5 like I did on previous problems? Well, if you're putting it in radical form, you want it in simple radical form. If you're leaving it in rational exponent form, you don't do that. So I just leave it like this. Okay. You can have what's called improper fractions. We use them all the time in algebra. Okay, so the second example, 25 a to the 4th b to the minus 1, the whole thing raised to the 1/2 power over parentheses 2a to the 1/5 b to the 3/5 close parenthesis, that whole thing cubed. Okay, so there's several ways you could do this. Remember, 1/2 power here means square root. And so the square root of 25 is 5. Square root of a to the 4th, of course, that's just multiplying the exponents. You just get a squared, right? And then 1/2 times minus 1 here is just the minus 1/2. And then I'm cubing the ones on the bottom. So 2 cubed is 8. A to the 1/5 cubed is a to the 3/5. Just multiply 3 times 1/5. And b to the 3/5 cubed is, you multiply 3/5 times 3, you get b to the 9/5. And now I need to combine the b's and the a. So I'm just going to bring this b to the minus 1/2 to the denominator and bring the a to the numerator, because that way both of them give me positive exponents. Positive exponents, sorry. So I get this. Now these are the exponents. A has this exponent 2 minus 3/5. B has the exponent 9/5 plus 1/2. I need the common denominators to add those together. So on the top, the common denominator is 5, and on the bottom it's 10. And the denominator is 10, the common denominator of the exponents. So I get 5a to the 10/5 minus 3/5 and 8b to the 18/10 plus 5/10. So that's going to be 5a to the 7/5 over 8b to the 23/10. Okay, and I just leave it like that. I don't try to simplify it because it doesn't simplify further than that. And we're leaving it in rational exponent form, not putting it in radical form. Okay, so that's it for that section.